Hey guys, Nuclear Chem Day 3. Here we go. Aim. How do we differ and how do fission and fusion reactions differ? So, we're going to learn today about fission and fusion. Yes, fusion is what powers life on Earth. It's for energy from the sun. While fission reactions are found in atomic bombs, just like what you see over here, exploding right there. All right, so do now says write out the natural decay of each one. So, we've done it before. The mass on the left must equal the mass on the right of the arrow. So if you have 30 on the left, 0 plus what's 30? Well, while it's right now, hit pause, and we'll come back, answer the question below. Okay, we're back. So 0 plus 30 gives me 30. The atomic number on the left is 15. 1 plus what gives me 15? Well, 1 plus 14. So you guys simply go to your periodic table and look at the atomic number of 14. Well, Mg is 12, aluminum is 13, Si, silicon, is 14. Remember, guys, your atomic number is what tells you the element symbol on your periodic table. Okay, moving on. Let's do the next question here. Oh, first of all, is this natural or artificial? Well, I have 1 on the left, 1, 2 on the right. So 1 on the left and 2 on the right. This is natural decay or, okay, so we know this is natural, right? However, what type of decay of natural decay is it? Well, I see 0 plus 1e. Well, 0 plus 1e according to table O represents a positron decay. Because if you go to table O, guys, 0 plus 1e is positron. Okay? All right, here's another simple natural decay, because again, you have one element on the left and 2 particles on the right. 1 on the left, 2 on the right. Again, it's natural. Let's go over what type. Well, it says 0, negative 1e, according to table O. That is a beta decay. Okay? All right. So let's balance this out, guys. Mass left is 137. 0 plus what's 137? Well, that's 137. Time number left is 55. What minus 1 is 55? Well, it's got to be 56. 56 minus 1 gives me 55. Time number 56 is BA. Here we go. Let's move on. All right, so I have a really cool thing over here. You should watch it about Nagasaki. What happened there? So here's an example of fission reaction, guys. So what happened over here? Well, there's a neutron splitting up the nucleus. You notice over here, the nucleus split up into, count with me, 1, 2, and then we have these little particles over here. 1, 2, 3 neutrons, okay? So a fission reaction is when a nucleus is split into layered nuclei. We have 1, 2, and then 2 new elements and 3 new particles over here. So fission is to split. That is the first type of nuclear equation over here. Okay, we'll learn here. Fission. So guys, fission reaction takes place. Oh, sorry. Fission reaction. Let me go back. Fission. Come on, yay. Fission reaction. Okay. Is over here. Atomic bomb. Over here. Now, we don't have this on Long Island because they stopped it years ago. However, we have the highest electricity rates in the country. It's because they were producing they were building actually a nuclear power plant years ago called in Shoreham, Long Island. They stopped it because they're scared, if we're on Long Island, something happens, God forbid, we're all going to be, in trouble. So I'm sure if you've driven out of the state or upstate New York, you've seen basically this big dome with white smoke coming out of it. Now, if you don't know, but white smoke usually tells me it's steam, okay, or from water. This over here is called a nuclear power plant or nuclear reactor, okay, while this over here is an atomic bomb. As you know, the atomic bomb was dropped on Hiroshima and Nagasaki, okay? So, let's look over here. Very simple. We're going to have to determine which is a nuclear fission reaction over here. Well, let's see. Here's your arrow. How many particles on the left side of the arrow, guys? Well, the neutron, which comes across and slams into the nucleus, splits it up. We have a neutron plus uranium element. So we have 2 on the left. Here's your arrow, right? How many particles on the right here, guys? Count me. 1, 2, 3. So when you have 2 on the left producing 3 on the right, that is a fission reaction. Fission. Now, what's happening in the fission reaction? Well, guys, if you notice over here, look at the atomic bomb that blew up over here. Boom. Look at this nuclear power plant or reactor. It's giving off energy. In fact, it produces so much energy, these nuclear power plants, they power whole cities. Okay? So, what is happening here? Well, mass. Look at the mass over here, guys. The mass over here is 235 plus 1 is 236. Well, mass on left must equal mass on right. 140 plus 93 is 233. Then I see a 3 here. What's 3 times 1? Well, 3 times 1 is 3. 233 plus 3 gives me 236. Mass on the left equals mass on the right. Okay? 92 plus 0 is 92. 56 plus 36 is 92. 3 times 0 is 0. Mass is converted into energy. Tremendous amount of energy, guys, that powers nuclear power plants, power cities, and bombs, okay? Awesome. Let's do another fission reaction over here. So here's the equation, guys, all right? Do this question over here. What type of nuclear reaction is represented by this equation? We have 2 on the left, 1, 2, 3 on the right. What's the answer? That's right, fission. Very good, fission reaction. All right, so here's another question. Hit pause and do it yourself. I'll give you 30 seconds. Okay. One count. We have 1, 2 on the left of the arrow. Here's your arrow. 1, 2, 3 afterwards on the right. Again, that is a fission reaction. Why? What does fission mean? To split. You see how this particle splits up, and then they go their separate ways. Splitting of the nucleus, okay? Which releases a tremendous amount of energy. Here's a little clip here, Sum of All Fears. Moving on. Now, what's happening over here, guys? Deuterium, which is H2, hydrogen with a mass of 2. Oh, it combines. We have H with a mass of 2. This H is a mass of 1. They're going to combine. Well, 1 plus 2 will give me 3. He3. So what's happening here? These two particles are smashed into one another, producing a tremendous amount of energy. All right? This is what's called a fusion reaction. So what does fusion mean? Well, fusion means to combine. What does fission mean again? Fission means to split. So here's an example of fusion reaction, guys. I have over here deuterium. Well, look at this, is mega volt, millions of volts. All right. So let's do this one more time. Hydrogen with a mass of 2 plus hydrogen with a mass of 3. Well, hydrogen was hydrogen, 1 plus 1. This gives me a mass of 4 plus, well, 4, 2, He, plus 1 neutron. Mass on the left must equal mass on the right. Don't get confused, guys. We'll show this and I'll show you next slide. Very easy. Okay, let's move on. Let's go. That's what I'm talking about. Fusion, guys. Fusion. Look at the fusion reaction here. Okay. Well, we see this beautiful object on the left. What is that? That powers life on this planet. That's right. It's the sun. The sun. And this reaction on the right over here is the most powerful bomb ever produced. It's what's called a hydrogen bomb. So now imagine the atomic bomb, which was dropped on Fukushima, I'm sorry, not Fukushima, I'm sorry. On the two Japanese cities, on Hiroshima and Nagasaki, those two cities were ruined because of the fact of the atomic bomb. Now imagine if the Americans dropped this bomb. Well, they're lucky, the Japanese, they didn't have this bomb at their disposal. This bomb, the hydrogen bomb, is 1,000 times stronger. That would have just leveled. We're talking tens of miles, thousands of square miles, even more, of devastation. Who knows how many more millions of people would have been killed. Thank God they didn't have that capability back then. All right. So mass is converted. And again, what's happening here, guys? Well, we have 2 plus 3 gives me 5 on the left, 5 on the right. Well, mass on the left equals mass on the right. 1 plus 1 is 2. 2. So what is the key phrase over here you need to know? Just memorize, guys. Memorize. Hydrogen plus hydrogen gives me helium. Okay. Over here, again, what's happening? Hydrogen plus hydrogen gives me what? Helium. That is fusion. Because what's happening is they're combining. All right. Hydrogen plus hydrogen combines to form helium. 2 plus 3 is 5. 4 plus 1 is 5. 1 plus 1 is 2. 2 plus 0 is 2. Again, what's happening here? Mass is converted into energy. So, guys, let's do a quick recap. Both fission and fusion reactions, mass is converted to energy. All right? Sorry, I don't know what happened here. It's like it's been doing this lately for some reason. So, mass converted to energy. All right? So that's what they both do. All right. The difference is fission means to split, fuse means to combine. So here's a Regis question here. All right. Fission and fusion reactions both release energy. However, only fusion reactions. Hit pause and do this question here. All right, we're back. Well, if you remember we saw before, it was hydrogen plus hydrogen gives you helium, right, guys? Hydrogen mass of 2, this could be a 3 or 1, doesn't matter. This is 5, let's just say 1, 1, and 2. So the nuclei over here are pretty light, aren't they? It's not uranium with a mass of 235. There's only 2, mass of 3, mass of 5. So they combine light nuclei, okay? They don't require elements of large atomic numbers. They don't create radioactive products. Helium's not radioactive, right, guys? What do we use helium for? Oh, balloons, stuff like that. Okay, let's move on. There's no radioactive reactants. Hydrogen's not radioactive. All right. And that's it.